So hi and welcome everybody to the lecture of wireless security course. Welcome back everyone. So in the previous lecture we talked about few core technologies related to 5G networks. And among these technologies we discussed the following ones. Software-defined networking, the first one. Software-defined networking, and then mobile edge computing, slice networking, and software-defined radio as part of a technology that's coexisting with the core network of 5G. And we stopped at network slicing, and we said network slicing is the separation of multiple virtual networks that operate on the same physical hardware for different application, services, or purposes. So let's understand this from IT perspective first before we go to the 5G core network. And let me share with you this picture here. So as you can see here from this picture, we have something we already know from IT called virtualization. We have something called hypervisor, VMware. So if you were to use like multiple operating systems on the same hardware, on the same PC, what would you do? So one of the easiest way to do this is to install a software or a package called VirtualBox. You install it on your PC as just regularly as a normal program or software or an app. You download it on your device. And then on top of this, in this device, you can install dedicated operating systems that can take some resources of your computer. You allocate just certain resources in terms of CPU, memory, RAM, hardware, whatever, and you can use, for example, Mac inside Windows, or use Ubuntu inside Mac, or vice versa. You can use all the operating system on top of just one PC. So this is really cost saving, because you don't need, if you want to experiment with Mac, you don't need to buy a new laptop. You just can install it in the same laptop and use all the applications that are designed for Mac. If you want to use the applications for Android, you can just install Android and use the application for Android. All the operating systems, all the applications that are available only for those operating systems, you can make use of them by just installing hypervisors in your PC. And this is very well known in the IT industry, and it has been used extensively. And now there is a new concept also called Docker. So Docker here in this concept, you have the hardware, whether it's a server or a PC or whatever, and you install on top of this a certain operating system. Let's say Ubuntu or Windows or whatever. And on top of that operating system, you install a Docker engine. Now the magic happens in the Docker engine, where where this engine allocates and dedicates certain resources just for the operating system that are going to be run above the original operating system. So for example, each one of the operating systems that are installed on top of Docker are going to have their own CPU, their own RAM, their own network functions, their own resources, and those are isolated totally and completely from the rest of the operating systems. So you can think of the difference between VMware and Docker is that VMware virtualizes the hardware, while Docker virtualizes not only the hardware but also the operating system resources. And those are two well-known concepts in the IT and has been used extensively, especially with the emergence of the cloud. The same thing is being borrowed and implemented in 5G. 5G is going to use all these amazing IT technologies regarding VMware and Dockers and some other ones as well, which are more advanced than this. But as you can see, the main benefit of using such a technology is the fact that using the same hardware, the same resources, you can have multiple operating system, which means in the 5G world, you can have multiple operators running on the same you are running on the same hardware devices or using the same towers or cells or whatever. They just isolate the technology isolates the operators from each others by just dedicating resources and allocating operating systems for them. And these operating systems, think of them like the applications in 5G. I mean, a design that's dedicated only to serve drone-based applications, a design that's dedicated to serve only industry or factory-based services and applications, a design or a virtual network that's dedicated to serve ultra-reliable low-latency communication. So all these are amazing things that are going to open really enormous, huge amount of opportunities, and like we are going to see unbelievable advances and new technologies and applications emerging due to the utilization and adoption of such thing called virtualization, especially for developers, where developers can access the resources of the 5G network and start building apps that can have some of the 5G core network resources. So going back here, this is the network slicing concept, where you have a virtual network dedicated to Internet of Things devices or healthcare or mobile broadband or physical hardware, whatever. And we talked about some of the security issues and challenges regarding network slicing, and we mentioned that there are key security issues related to network slicing. The first part is security issues related to the new verticals that these virtualized machines are going to serve, like e-health, autonomous driving cars, smart grids, wearable, smart homes, industry 4.0, drones and UAVs, virtual reality, augmented reality, mixed reality, and some other things as well. Tactile internet and so on. So this is the first part, security issues related to new verticals, and there are security issues related to the 5G communication infrastructure from the device to the core network. For example, when you think of the security in 5G, you don't just consider only the air interface. You have the device security. So device security includes the operating system, the applications, the services, everything on the device, whatever. And so device threats, the device is like subject to too many threats, including bots, distributed denial of service, man-in-the-middle attacks, firmware attacks, device tampering, malware, sensor susceptibility. So all these are critical security threats that can happen at the device. Now, on the air interface, the connection between the device and the radio, the tower, the cell that provides the wireless signals, we have a few attacks as well, and we discussed some of them, including jamming, eavesdropping, spoofing, and man-in-the-middle attacks. And those are very critical, and we emphasize too much on jamming, where we said like a hacker or an attacker can really bring the network down with just jamming, by just sending interference signal to the network. And that's so critical. We also discussed about edge network threats. Edge, which means that you bring some of the software or cloud resources and you put it near to the tower or cell in order to make in order to be able to serve the data to the users in a much faster manner, where users don't need to wait for long until they see the video. So we have the mobile edge computing server vulnerabilities. This is the first threat at this level. You have the rogue nodes, you have the authentication issues, the slide channel the side channel attacks, the improper access control. Those are key issues related to the edge. So up until now, we have three sections. We have the devices and the applications on top of these devices and their operating systems. We have the radio access RAN, and we have the edge, the cloud resources that are being moved and shifted to be near to the tower or cell so that they can serve the user easily. We have the fourth one, the fourth level is the core network. So the backhaul and core. The backhaul is the connections. Backhaul, basically the connections from the edge network to the core network, where you have the servers that store the data. Among these attacks that can threaten this network in 5G, we have distributed denial of service, where you have multiple nodes launching multiple nodes exploiting the resources of the network and making the resources busy so that nobody can be served from the authentic legit users in the networks. We have the control and user plane sniffing, mobile edge computing, backhaul sniffing, flow modification attacks. All these are threats that can exist on the core. We have also software issues, API vulnerabilities, network slicing issues, the same DDoS, improper access control, virtualization issues. The last level is the external network threats, where you have app server vulnerabilities, cloud service vulnerabilities, bots, and other IP-based attacks and hacks, application vulnerabilities, API vulnerabilities, roaming partner vulnerabilities. All of these are threats that exist in the 5G network. So it's really a huge, massive area. You cannot really cover everything and become expert in everything. Usually, each section, each level of these has its own expert people. So some people are expert in securing the application, the device. Some are expert in securing the link between the device and the towers. Some are expert at the edge. Some are expert at the core. Some are expert at the external. So it's really massive and huge. And this picture just clearly shows you the huge amount of security, the huge number of security issues that you might experience and face in 5G. So 5G security requirements. Of course, the 5G security requirements are going to be similar to the ones we discussed before. Generally, authentication, confidentiality, availability, and the privacy. Those are the key security requirements. And we have, but here, those requirements should be met and satisfied and achieved at different levels of the network, including the user equipment, the access network, the core network, the service, and the application. And there are general, so for the user, you need mechanism that can protect against malware, side channel attacks, and zombies, and whatever, viruses, and so on and so forth. Access, air interface security, MIC security, SDN security, network function virtualization security, cloud security, and so on. We have the core network security as well, with its own things, with its own stuff. We have service application security here as well. And service application security is one of the most security domains that are really happening right now in the world. Why? Because everybody, we are mostly dealing with applications when we use the internet. Yes, you either use a website or an app installed on your phone or whatever. And most of the security threats are happening there at the application level. So you have web security, cloud security, information security, database security, big data security, And the software itself that builds that app or that website is also vulnerable to security threats, so you need to secure it. So the security enablers for achieving the security requirements at different levels are mentioned in this box, including cryptography, quantum safe cryptography, security situation awareness, security emergency response, IDM, PKI, DLT, AI, ML. So I believe most of you are aware of these acronyms and you have seen them, and like DLT for blockchain, and AI, artificial intelligence, machine learning, and some other technologies that are key to enable the security at different levels of the 5G core network. So in summary, the 5G security model can be summarized in this slide, where you are striving and fighting to achieve the following things: the integrity, the availability, the visibility, the centralized policy, and confidentiality. You want to achieve all things all together. There are some pros and cons. 5G technologies and network softwareization can also help improve the security. Basically, in the previous slides, we showed you how these functions, how these new technologies can be exploited and can be hacked and attacked. But also on the other side, they can facilitate improving the security of the network. So talking about network softwareization for 5G, we have the benefit of here we explain the benefit of softwareization for 5G in terms of security. So it can help improve the following: it can achieve fast deployments and update of security mechanism very quickly, very fast. It can also achieve centralized security control and granular policy management, where it's just one centralized cloud that manages and monitors everything. You can also optimize the security resources and reduce the cost, open the new ways of delivering security. Example, you in the future, many researchers are expecting that a new type of services called security as a service is going to be a killer application in the future technologies, because like most of the applications, most of the devices are being secured from just certain attacks, just certain threats, and those are just related to regular normal individuals. But what if you want to make the security really perfect? What if you want to make sure that this user or this user is basically a VIP person, and you want to secure everything related to his or her communication, and you want to make it like you give that user a guarantee that nobody will ever hack you or attack you, and if that happens, then we will it's kind of an insurance, and we will substitute you. uh, we will compensate you for the loss you or damage that security threats or security attack has caused to you. So this is going to open large number of opportunities actually, and this is where the security engineers are focusing. And the last one is increased scalability and flexibility. Of course, I mean, with softwareization and the cloudification, sometimes people call it like this. If you have a website or you have an app and the number of users using this app increases rapidly, you are not stuck with just limited resources, and you say I cannot serve any more users. You can easily expand to more memory, more CPU, more cores, more network resources, and that's fine. You are good to go. You can serve unlimited number of users as long as you can expand easily. So fast deployment and update of security mechanism, there is no dedicated security hardware needed to upgrade. Basically, it's all software based. There is no hardware things. It's super easy, super fast because software is easier to deal with. This is one of the key advantages and merits. And you have centralized network, not distributed, where one node is controlling everything. All 5G technologies, including SDN and NFV, MEC, and others, support the centralized control and orchestration. So this enables global visibility, and the global visibility allows uniform security and policy deployment. And all these are extremely desirable features. We have also the optimization. Optimization for this functionality, you don't need any dedicated hardware devices to achieve it. You can achieve it with software, and you can share the resources in time. For example, X user is using the network from 4 to 5, but then he frees the network, he doesn't need it. You can just allocate the service or the resources to another user who's in need of these resources. So better optimization or fine-tuning of security mechanism due to global visibility, because you see all the users, you see how much bandwidth they are consuming, you see how much CPU they are using, how much core they are utilizing, and you just monitor all of these and map the requirements of the users to the existing resources, so it becomes much more efficient. Think of this like the shared riding cars. Like in the practical world, each one currently has, for example, many people they have their own cars, and their cars just parking all day long. They don't use it. If they use it for a few minutes, few hours, and then it just idle. It's there, nobody making use of it. So this we call it waste of resources, something that's not being utilized to its full capacity, to its full capability. And that's not good for the community, for the economy, in general. You will not benefit much from what you have from resources and so on. So it's better that if we have a centralized node that can have access to the availability of these resources all the time, then we can map these resources to the people who need them. So open new ways of delivering security. We have, as we mentioned, we have the security as a service via mobile edge computing and slicing. It's worth to mention here that security as a service is not dedicated to just mobile edge computing and slicing. You can apply it at the device, at the application, at the operating system level, even at the interface. So it can be at different levels of the network, but the core idea of it is just improve the security as per the requirements of the users. Increase the scalability and the flexibility, ability to dynamically scale up by using cloud resources. We already mentioned this. Now we can stop here for this and continue after a few minutes. Thank you, everybody.